This video lecture is meant to cover the information found in Chapter 2, Sections 1 and 4. Chapter 2 is about matter and change, and we're going to start with Chapter 2, Section 1 on properties of matter. Now, there's lots of ways to describe matter, and to categorize those ways that we can describe matter, we refer to something that is called extensive properties and intensive properties. And if you know your prefixes, ex versus int, this gives you an idea as to whether or not these properties are inherently part of the substance or if they are not inherently part of the substance. For example, extensive, ex meaning outside of. An extensive property is a property that depends on the amount of the matter in a sample. It doesn't matter what that substance is made of. If you have a different amount of mass, volume, or length of a substance, then that's going to change. So, for example, if you were to have a piece of gold in your hand, the mass of that gold is going to depend on how much gold you have in your hand. Same for the volume and the length. All right, so the amount or the mass of the gold is not inherently part of the gold. That's what we call intensive properties, properties that depend on the type of matter, not the amount. So these are things that you can identify a substance based on intensive properties. Examples here include density, color, MP is melting point, BP is boiling point, and soluble, whether or not a substance is soluble in water. All right, so if you know those properties, the density, the color, the melting point, the boiling point, and the solubility, chances are you can identify that substance. Just knowing the mass, the volume, or the length, you can't necessarily identify what that substance is. Identifying substances, well, first of all, I see that this term substances here is underlined. When we refer to substances in this course, a substance is referring to either an element or a compound, and we'll get to those definitions in a little bit. Okay? But a substance, either an element or a compound, it's a type of matter that has a uniform, a consistent and definite composition. Meaning, every sample of that substance will have the same intensive properties, the same density, the same color, the same melting point, etc., etc. You can identify a substance based on those physical intensive properties. Okay, so to define physical property, it is the quality of a substance that can be observed or measured without changing its composition, without changing its identity. Examples of physical properties: viscosity, how thick something is when it's a liquid; density, how much matter is packed within a given space; malleability, how bendable it is; ductile, how stretchable it is; and brittle, how easily it can break. Here are some videos that kind of demonstrate viscosity. Right here in this picture right here, we've got two liquids. I'm going to pause these. Okay. In this first video, we have a liquid with a low viscosity. It easily pours. Now here's the second liquid that has a high viscosity. So viscosity is defined as the resistance to pouring. And this is a very thick liquid like you would see with honey or molasses or Karo syrup or an oil for your car. There are different viscosities of oil that you can buy when you do your oil change in your car depending on the season. Density. Diet Coke. A can of Diet Coke will float in water, but a can of regular Coke will sink. The reason for this is the regular Coke has sugar in it, making that can on the right have a greater mass than the can on the left, which has no sugar, so it'll have less. The Diet Coke will have less mass, but notice they have the same volume, the same size can. So the sugar on the right will add more mass, making it more dense than the Diet Coke. That's just the video showing you that the amount of sugar is 35 grams in the Coke, and in the Diet Coke there's only 2 grams of aspartame, making the mass less in the Diet Coke. If we were to take a look at this video right here, this is going to show you the malleability of metals. When it's here, we've got a piece of iron that's been heated up, and you can bend it. Okay, this is what malleability is all about. You can bend it, you can shape it, you can form different shapes from it. And I think this particular video is showing you how nails used to be made by hand. Right, so here they're pounding the nail, the head of the nail, so you can get the shape of the metal into whatever form you needed. So that's malleability. Here they're going to show you ductility. This is a rod of metal that is going to be stretched in this stretching machine. It's taking that very thick cable and it is drawing it into thin wires. So ductility is the ability of a substance to be pulled or stretched thin into thin wires. While that video is showing, because that one's a little slow, a little dull, the video on the right is showing, let's see if I can rewind it here. Right, this is showing you putty when it is, silly putty is an interesting substance because it is both malleable and then it is brittle at the same time. So with enough force it will shatter. So here you can see with the initial impact that it bends, but at some point it becomes brittle and shatters into a gazillion pieces. Okay, so here we've seen viscosity, we've seen density, malleability, ductility, and what it looks like when a substance is brittle. Moving on, states of matter. Solid, liquid, and gas, you know these, okay? So here's a picture of a substance when it's solid, here's a picture of something when it's a liquid, here's a picture of something when it's a gas. It is the sideways pictures, I apologize for it, I was trying to fit it all on the page. Okay, if we consider a solid has a definite shape and volume, and the particles are packed together tightly and orderly. Here is an animation of a substance that is in the solid form. We are looking at it through a magnifying glass or through some sort of microscope so that we can see the particles. They're packed together tightly in a regular pattern. They are moving, but they're just sort of staying in place and kind of vibrating. A liquid has a definite volume, but it will take the shape of its container. The particles are close, but they're not as orderly as they would be if they were in the solid form. If we take that solid and apply some heat and melt that solid into its liquid form, now we can see that the particles are, they are still packed closely together, but they're no longer in a nice pattern. They are sort of randomly moving around. They're not neatly arranged like they were with a solid, but they are still close together. A gas can expand or condense easily, so therefore it has no definite shape, and it will take the shape of its container. The particles tend to be far apart and not orderly at all. Okay, and FYI, if you hear the term vapor, vapor is the gas form of a liquid, a substance that is normally a liquid at room temperature. But when a substance that is normally a liquid is at room temperature, when it's in the gas form, we refer to it as a vapor. So really just want you to know vapors is really the same thing as the gas state of matter. Here we see that same substance heated up a little more until it's in the gas phase. You can see that the gas particles are moving much faster than they were in the liquid phase, and they are much farther apart. Lots of space between the particles. And so here you can just see this is an animation of the differences between the particles and how close they are together in the three different states of matter. Physical changes. The definition of a physical change is when the substance changes, but not its composition, not its identity. Physical changes can be reversible changes or they can be irreversible changes. Reversible changes tend to be the changes in state: boiling, melting, freezing, condensing. Irreversible changes is when something breaks, splits, grinds, crushes, cuts. Any kind of change in shape or size are what we would typically refer to as irreversible changes. There are some pictures that go along with this. Here we can see reversible changes. Here's a picture of water boiling. Here's a picture of water condensing from the gas to the liquid phase on the outer surface of a bottle outside on a hot summer day. Here we see an ice cube melting. This is when a substance goes from a solid to a liquid state. All of these are reversible by just changing the temperature of the substance. Irreversible changes, here something's being pulverized by this martial arts expert, right? Once something is pulverized, it's near impossible to put it back into its original form. Here's a tear of the meniscus of the knee. Tear is possibly can heal, but once it's torn, you can't actually patch it back together physically. And here's a funny picture of a cat getting a haircut. Once those hairs are cut, you can't reattach them. Yes, a cat can regrow those hairs, but that's not quite the same as reattaching the hairs that have been cut. So pulverizing, tearing, and cutting, these are just some 3 examples of irreversible physical changes. Section 2.4 is about chemical reactions, so we need to talk about what a chemical change is. A chemical change is when the composition or the identity of the matter changes. Any chemical reaction is a chemical change, and you start out with, whatever you start with is called reactants, and what those reactants turn into is what we call products. For example, if your car is rusting, the metal of the car before it's rusted is what we would call the reactant, but the rust is the product. The rust is what the car's metal turned into. So these are terms that we'll get used to using in chemistry this year. A chemical property is defined as the ability of a substance to undergo a chemical change. Examples of describing a chemical property of a substance is if it burns, if it ferments, like grapes when they turn into wine, if it explodes, if it corrodes, or if it oxidizes. That example of your car metal rusting, that's an example of a corrosion or an oxidation reaction. The 4 clues to recognizing that a chemical change has occurred. If you see a temperature change, either getting hotter or getting colder, this is a transfer of energy. Typically, this is what you would see. If you see a temperature change, it is likely due to a chemical change. If there is a change in color, if there is a gas produced, or if there is a precipitate that is produced. A precipitate, as you learned in the laboratory, is a solid that forms and settles out after 2 liquids have combined. The last piece of this lecture is the law of conservation of mass. A definition of the law of conservation of mass is when matter is neither created or destroyed, it is just converted from one form to another. Now, one of the things that you can take from this is that whatever the mass of all your products is, must be equal to the mass of all your reactants. So let's say you had a chemical equation, a chemical reaction where you have iron reacting with sulfur. These, F and E plus S, these are your reactants. FeS, iron sulfide, is your product. Let's say you know this much information. Let's say you know you started with 5 grams of iron, and let's say you know that you ended up with 15 grams of iron sulfide. The question is, how many grams of sulfur would you have needed to make this happen? And the answer is 10 grams, right? The mass of both reactants has to add up and equal to the mass of all your products. Last question for the lecture. Can you identify which Unit 2 objectives we learned about today? It's objectives numbers 2, 3, 4, 5, and 6. We listed examples of physical properties and chemical properties. We defined and distinguished between extensive and intensive properties. We distinguished between physical and chemical changes. We listed observations that suggest a chemical change has occurred, and we applied the law of conservation of mass to chemical reactions. This concludes this video lecture on matter and change. See you in the classroom.